Okay, so welcome to the deep dive, everybody. Today we're really getting into something kind of fundamental to, well, pretty much everything we do. How we learn and process information.
It really is fundamental, isn't
It
it?
is.
Yeah.
And, we're specifically going to look at the concept of working memory, that mental workspace we use, to hold on to new ideas, even for like simple things like learning a new dance move. And we know that you guys listening, you're all about, really understanding this stuff
Yeah.
without, getting too bogged down in the weeds.
Absolutely. Make it useful.
Yeah.
Yeah.
So our mission today is to kind of take these complex ideas, make them clear and useful, and maybe even a little bit surprising.
Yeah, and hopefully a little bit of fun along the way.
Yeah.
And you know what we're going to base this entire exploration on is a really thought-provoking article called Cognitive Load Theory and Human Movement, or
Oh.
Integrated Model of Working Memory
Mhm.
by Sepp and colleagues. It came out in 2019,
Mhm.
and it offers a fresh perspective on how our understanding of working memory is evolving.
Right.
And kind of crucially, how it connects to this really fascinating role that our bodies play, particularly movement, in how we learn.
Yeah.
So that's kind of the crux of where we're going today.
Okay, so let's start with, just the basics here. Working memory, we're talking about, more than just short-term memory.
Right.
The article kind of takes us all the way back to some of the foundational ideas and, one of the classics, a really classic notion from way back in 1956.
Oh, wow.
George Miller suggested that, our brains could only juggle like 7 plus or minus 2 bits of information at once.
The magic number 7, yeah.
It's kind of like that idea of a really tight squeeze
Yeah.
on our mental processing power.
It's interesting, though, right off the bat, that 7 plus or minus 2, as influential as that idea has been, it has been debated quite a bit since then.
Right.
And, some researchers now think it might be closer to like 4 items or even fewer,
Oh, wow.
depending on what we count as an item
Right.
and the situation we're in and what we're doing with that information.
Right.
But, this highlights, I think, that even from these earliest understandings of our mental limits was more nuanced than it might seem at first glance.
Yeah.
So for you, the listener out there, I think what this suggests is that our ability to hold like a lot of new things in mind at once is actually quite limited.
Yeah.
It's not this infinite well that we can just pour tons of information into.
Right.
There are constraints.
Exactly. And then the discussion moves to the Atkinson-Shiffrin model from the late 1960s.
Right. Yeah.
Which kind of painted this picture of memory as this 3-step process. So information first hits our senses, and then if we pay attention, it moves into like short-term storage.
Okay.
And then with enough processing there, it can get tucked away into our long-term memory. So what was the big takeaway there for our understanding of learning from that model?
Well, I think if we connect this to how we learn, the Atkinson-Shiffrin model really emphasized, the crucial role of attention.
Okay.
It showed us that there's a gatekeeper or a focus that decides what information even gets a chance to be processed beyond that initial sensory flash.
Yeah.
So we're constantly bombarded by sights and sounds and feelings, but only a small fraction of that actually makes it into our working memory system to be further processed. It also started to hint that different types of information, like sights versus sounds, right, might be handled slightly differently even in that short-term holding space. Think about trying to learn a new word.
Yeah.
You might see it written down, you might hear it spoken aloud, and those feel like quite different experiences in your mind.
Absolutely. Seeing a new word versus hearing it. Definitely. Different parts of your awareness are engaged, for sure.
Yeah.
Now, the article then moves on to what many people consider, a real turning point, and that's Baddeley and Hitch's multi-component working memory model. From 1974, this wasn't just about holding on to information briefly.
Yeah.
It really introduced the idea of actively working with it. So can you give us the highlights of that model and kind of what it meant for how we think about learning?
Yeah, absolutely. So Baddeley and Hitch, they really shifted the idea of short-term memory to a more active working memory system.
Right.
So they proposed this idea of a central executive. It acts kind of like the brain's our traffic controller.
Okay.
Right? It's directing attention. It's managing 2 main helper systems, if you will. One is called the phonological loop.
Okay.
And that deals with anything that's sound or speech-based. So that little voice in your head when you're reading, that's your phonological loop at work. The other one is the visual-spatial sketchpad, which handles visual and spatial information, right? So figuring out directions, learning a physical skill, like a dance move that you mentioned.
Right.
That would heavily rely on that visual-spatial sketchpad. And what was really significant here was this clear separation they proposed between these visual and auditory processing pathways. So if you're trying to follow spoken instructions while looking at a diagram, these would be handled somewhat separately in your mind. You wouldn't have to rapidly switch back and forth.
So almost like having separate mental sketch pads
Exactly.
for sounds and for images.
Yeah.
And then the central executive is kind of trying to coordinate them.
Central executive is the boss,
Right, exactly.
having everything running smoothly.
Exactly. And then Baddeley later on added another piece to this puzzle,
Right.
the episodic buffer. So what role did that play?
Yes, he did. So around the year 2000, Baddeley kind of realized that the original model didn't fully explain how we could create these rich, integrated mental pictures that combine information from both what we see and what we hear.
Okay.
So the episodic buffer was introduced as a kind of mental workspace, if you will,
Okay.
where visual, spatial, and verbal information could all be bound together. It also kind of acts as this bridge to our long-term memory, allowing us to pull in relevant past experiences and kind of combine them with what we're currently processing.
Right.
So if you're learning about a historical event, for example, you might access, visual memories of images you've seen.
Mm-hmm.
You might access verbal knowledge of dates and names and piece it all together in this buffer.
Okay, so we're kind of seeing this picture emerge of increasing complexity.
Right.
We moved from just the simple storage limit to separate processing systems and now an integrator. Now, the article also highlights Cowan's model from 1988. So how did his view differ from Baddeley's, and what did it tell us about the role of our focus?
Yeah, Kalman took a slightly different route. So instead of proposing all these separate systems for different types of information, he suggested a single central pool of attention that handles everything.
Okay.
So think of it like, a spotlight of your mental focus,
Right.
And so Cowan really emphasized that working memory isn't just about holding on to things, but actively selecting certain information and filtering out distractions using this attentional spotlight.
Mm-hmm.
So it's not just capacity, it's control.
Right.
It's how well you can direct that spotlight.
Right.
He also distinguished between simply storing information versus actually manipulating or working with it. So two different things. And interestingly, his estimate for our pure storage capacity, without using any memory tricks like repetition or grouping things together, was even smaller than Miller's initial suggestion, maybe only 3 to 5 items. So, and for you listening out there, this kind of underscores just how selective and focused your attention needs to be when you're tackling new information.
Interesting. So kind of a shift towards a more unified system.
Yeah.
Centered around our ability to pay attention. And it seems like this idea of an integrated attention system became kind of a key area for further development in how we understand working memory.
Absolutely. So Callan himself, in his later work in the 90s, and other researchers like Pasqualeone and Engel, really championed this idea of a single limited capacity system. Yeah. Engel in particular argued that working memory capacity isn't just about how much we can hold,
Right.
but more fundamentally about our ability to control our attention effectively to achieve our goals. So it's almost like having, a limited amount of mental energy.
Okay.
And how well you can direct that energy determines how well you can learn and solve problems.
So it's not just about like the size of our mental RAM,
Right.
but how efficient our mental processor is at managing focus.
Yeah, exactly.
Now, the article then brings in the work of Unsworth and Engel. What did they add to this understanding of attention in working memory?
Yeah, so Unsworth and Engel, they proposed a model where there were two things kind of happening simultaneously.
Okay.
One is our ability to focus our attention on what's important while actively blocking out distractions.
Right.
And the second is how we use cues, both from our surroundings and from our long-term knowledge, to make sense of the information we need for a task.
Okay.
So they really strongly supported this idea that attention is what they call a domain-free resource, meaning it's not tied to specific senses like seeing or hearing. It's a general mental resource.
Okay.
We tap into it for any kind of cognitive work. So whether you're trying to understand a complex graph or follow a complicated recipe, you're drawing on that same pool of attentional resources.
Yeah, that really resonates with those times when you're trying to concentrate on something, and even a small noise can just throw you off completely.
Absolutely.
Like you're constantly having to fight to keep your focus where it needs to be.
It is. It's a constant battle.
And this idea of a single attentional resource, the article connects this to something called the redundancy effect in cognitive load theory. So can you explain how that link works and kind of what it means for how we should present information?
Yeah. So this is where it gets really interesting for, how you learn things. If we have this single attentional resource, then if you're given the same information in multiple ways at the same time, say you're reading text on a slide while the presenter is reading that exact same text aloud, your brain has to use its limited attentional resources to process both of those streams of information, recognize that they're identical, and essentially filter one out as unnecessary. This uses up valuable mental energy that could have been used to actually understand and integrate that core message. So the format doesn't really matter. What matters is you're being given the same content twice, and that makes learning less efficient.
Makes perfect sense.
So for you out there, when you're learning something new, try to avoid situations where the same information is being presented simultaneously in different formats.
Yeah, it's like trying to listen to two people saying the exact same thing at the same time. It's just a waste of mental effort. Now, the article also touches on expertise. So how does this idea of an integrated attention system explain how experts in a field might process information differently from beginners?
So I think what this idea of a single attentional system suggests is that expertise isn't necessarily about having some kind of superior separate working memory system for that particular skill.
Yeah.
Instead, experts have likely developed much more efficient ways of using that single attentional resource.
Mm.
They've built up these extensive networks of knowledge or schemas through years of experience and practice.
Right.
So think about a chess grandmaster, right?
Yeah.
When they look at a chessboard, they don't see a collection of individual pieces. They see patterns. They see potential strategies almost instantly.
Hmm.
And this isn't because they have a better visual memory in general. It's because their experience allows them to process that information on the board much more efficiently,
Right.
knowing exactly where to focus their attention.
So it's about knowing what to pay attention to and what to ignore, which is a skill that you hone through experience. It's like they have a much more fine-tuned mental filter.
Exactly. Yeah. Much
Yeah.
more sophisticated filter. They know what's relevant. They know what's not.
And this leads to the idea that our attentional focus isn't locked onto one sense. It's constantly shifting and adapting.
Precisely. Our attention is like this flexible spotlight. It's constantly adjusting its beam based on a whole range of factors. Our past experiences, how much we already know about something, the mental energy we have available at the moment, and what the task in front of us demands. So for someone who's learned primarily by reading, they might naturally focus more on visual information, while someone with a lot of hands-on experience might be more attuned to the physical sensations involved. It's not about having separate mental compartments, but about how we tend to distribute our limited attentional resources.
And the article makes a really important point that even when information comes in through different senses, our brains don't necessarily have to do this rapid back and forth switching between completely separate systems.
Exactly. When we have these strong mental frameworks that connect information across different senses, like understanding a concept that has both a visual representation and a verbal explanation that fit together well, our attention can activate and consolidate and process this information within that single focus of effortful mental attention. This aligns with research on how we handle complexity, suggesting that it's the processing of the relationships between different pieces of information that really determines how much mental effort is required, not whether it's coming from our eyes or our ears.
Okay, so this shift towards a single, flexible, attentional resource
Yeah.
seems to be a really important development in how we understand working memory. Now, the article takes a really interesting turn and starts looking at the role of gestures and physical movement in all of this.
Yes.
So how do our actions fit into this picture of how our brains handle information?
This is where the integrated attention model really starts to show its power.
Okay.
Because research is suggesting that our gestures, they aren't just random fidgeting. They can actually play a significant role in supporting our working memory.
Really?
For instance, studies have shown that people who have a lower capacity in their visual spatial working memory, they tend to gesture more
Oh, interesting.
when they're trying to explain something visually. And that observing gestures that match what's being taught can actually improve learning, especially for those who aren't as strong in those visual spatial tasks. And there's even evidence that gesturing can reduce the amount of visual processing our brains have to do, as measured by eye movements.
Interesting.
It's like our hands are helping our minds.
So it's almost like the gestures are helping to offload some of that mental burden.
Yeah, that's a great way to put it.
Now, the article highlights two main ways that gestures might support working memory. Can you kind of elaborate on those for us?
Yeah. So first, gestures can act as a temporary external storage system. So by physically demonstrating something, like showing the size of an object or the direction of movement, you're essentially holding that information in your hands in the physical world. This can prevent the memory of that information from fading too quickly, freeing up your limited attentional resources
Right.
that would otherwise be used to actively keep that information in mind. The second way is what's called physical embodiment. So by physically acting out a concept or a process, you're essentially representing that idea in a different sensory modality. Through movement, through body awareness.
Okay.
This can make the concept more concrete,
Right.
and it can focus your attention in a more effective way. Think about trying to understand how gears work.
Right.
You might instinctively use your hands to mimic their rotation,
Yeah.
and that physical action can actually aid your understanding.
It makes a lot of sense intuitively.
Yeah.
I can definitely see how physically acting something out could make it easier to grasp. But the article also points out that not all gestures are helpful.
Right.
There can be a downside.
Absolutely. That's a really important point to keep in mind,
Yeah.
both for your own learning and when you're trying to explain things to others.
Right.
Gestures that are distracting
Right.
or that don't relate to the task at hand or that simply repeat information that's already being presented in another way can actually hinder learning.
Right.
Because now your attentional resources have to be used to process and potentially reconcile this irrelevant or duplicate information, pulling focus away from the essential material you're trying to learn.
Right.
So it's a delicate balance.
And this idea of our working memory kind of getting used up or depleted,
Yeah.
how does gesturing relate to that? Can moving actually help us kind of sustain our mental effort?
Yeah, that's a great question. So this concept of working memory depletion suggests that our ability to maintain focus and process information isn't endless.
Right.
It can get worn down with sustained mental effort.
Right.
The article proposes that gesturing might help us kind of manage this depletion.
Yeah.
It's not necessarily refilling our mental tank, but rather it could be slowing down the rate at which our attentional resources get used up
Okay.
by offloading some of those demands onto the physical act of gesturing. So by using our bodies to represent information, we might be reducing the strain on our purely mental working memory systems.
Okay, so we've kind of journeyed from those early ideas about working memory to this more modern view of a single attentional resource.
Right.
And now we're seeing how even our physical movements can play this crucial role in how we learn and remember.
Exactly, yeah.
This brings us to the central proposal of the article, the distributed attention model.
Right.
So what's the core idea behind this model that tries to kind of tie everything together?
Well, the distributed attention model is really an attempt to create a more unified and comprehensive way of understanding how all these different factors we've been talking about, gestures, the influence of experience, expertise, and how our attention seems to be spread across various types of information.
Right.
It tries to bring all of that together.
Okay.
And it suggests that we have a single but limited pool of attentional resources that can be distributed across multiple foci.
Yeah.
And these foci aren't just the traditional senses like vision and hearing, but also include our physical movements
Okay.
and potentially even other things like our existing cultural knowledge or our current emotional state.
Okay, so it's a much broader view of what our attention can be directed towards in the process of learning.
Absolutely.
Can you break down kind of the key parts of how this distributed attention model works?
Yeah. So at the most basic level, you have the external stimuli that we encounter in the world,
Right.
and the moving inward, the model describes a periphery of attention. And this includes information that isn't our main focus, but still captures some of our attentional resources. Things that we've learned so well, they're almost automatic. Things that are brand new.
Right.
Things that are really salient or noticeable, or even things that might be misleading us. And then right at the center, you have the focus of attention.
Okay.
This is where we're actively, intentionally processing information. This central focus can have different foci within it, representing those different modalities or types of information we talked about: visual, auditory, embodied movement, and potentially many others.
Okay.
Yeah.
And so what determines which of these different areas of focus kind of get our limited attention at any given time?
That's the key question, right?
Yeah.
So the model proposes that there's this central limited capacity control mechanism for our attention. So our existing mental frameworks or schemas and the cues that are present in our environment are constantly competing for our attention. And this competition is what determines which of these different areas of focus gets selected for processing. Our individual attentional inclination, So this is something that's shaped by our past experiences, our expertise in a particular area, and even our current goals plays a significant role in how our attention tends to be distributed.
Right.
So this might help to explain why different people have different learning styles or
Mhm.
prefer different approaches to tackling new information.
And when we're actively processing information in these different areas of focus within our central attention, are they being handled in isolation or is there interaction between them?
They are definitely not being handled in isolation. The model really emphasizes that these different areas of focus are processed interdependently. So there are connections between them, and these connections can lead to either reinforcement, like when seeing a diagram perfectly complements a spoken explanation, or interference,
Okay.
like when what you're seeing visually contradicts what you're hearing.
Right.
And the stronger the connections between relevant foci Tversky, the more effectively we can kind of build integrated understanding.
So it's a really dynamic system where our attention is constantly being allocated and reallocated
Absolutely.
based on what's happening around us and our own internal state and knowledge. Now, the article goes on to explain how this distributed attention model can help us understand some of those well-known effects in cognitive load theory that we touched on earlier. So let's start with the goal-free effect. How does this model explain why sometimes we learn better when we're not explicitly focused on a specific outcome?
That is so interesting, isn't it? So the goal-free effect shows that when learners aren't kind of fixated on achieving a particular end result, they can sometimes learn more effectively. The distributed attention model explains this by suggesting that without a specific goal in mind, there are fewer active areas of focus demanding our attentional resources for constantly evaluating our progress
Right.
towards that goal.
Oh.
This frees up more of our limited attentional capacity to focus on understanding the underlying principles and the relationships between different elements of the task itself, which can lead to a more robust and flexible understanding in the long run. It's like taking the pressure off the final score.
Right.
Allows you to actually learn the fundamentals of the game better.
That makes sense. It's like taking the pressure off the finish line allows you to better appreciate the journey and kind of the details along the way. What about the split attention effect, where having related text and diagrams separated on a page can actually make learning harder?
Yeah, so the split attention effect, this happens when learners have to mentally try to connect information from sources that are physically separated. Like you have to look at a diagram on one part of the page and read the explanation on another. Our model kind of explains this by highlighting the cognitive cost of having to constantly switch our visual attention between these different foci. So while you're scanning back and forth, your attentional resources are being used to maintain the activated information from each source rather than being used to actually build connections
Right.
and create that unified understanding of how they relate. When the diagram and text are integrated, it reduces this visual searching and switching, freeing up more mental resources for actual learning.
Hmm.
So for you out there, look for materials that integrate related information directly.
And what about the modality effect, where often it's more effective to present some information as audio rather than all as visual, like having a narrator explain a diagram? How does the distributed attention model account for that?
The modality effect is really interesting, where learning is often enhanced by presenting some information auditorily rather than visually, like having a narrator explain a diagram rather than just having more text.
Right.
Our model explains this by the idea that we're reducing interference by using both auditory and visual channels as different areas of focus. When you have two competing visual sources, like text and an image, they can both be vying for attention within the same visual processing focus. But by combining auditory input with visual, it helps to distribute that processing load across different attentional foci, leading to more efficient processing and the creation of more integrated mental representations with less cognitive strain. Also, auditory information often has this kind of transient nature, being processed in the periphery of attention and then fading, which can sometimes be more efficient for certain types of information.
And then there's that redundancy effect again, where, as we discussed earlier, presenting the same information in multiple ways simultaneously can actually hurt learning. So how does this model further explain why that happens?
Yeah, the redundancy effect shows that when the same essential information is presented in multiple formats at the same time, it can overload our working memory. Our model explains this by emphasizing that our attentional resources are wasted in processing and then reconciling this duplicated information across different attentional foci. So your brain is essentially doing extra unnecessary work to process the same thing twice, taking away from the limited resources available for actually learning new aspects of the material or making deeper connections.
And finally, the expertise reversal effect, where teaching methods that are really helpful for beginners can actually be less effective or even hinder learning for more experienced individuals.
Yeah, this one's a classic. The expertise reversal effect occurs because experts already have well-developed and efficient mental frameworks, or schemas, for understanding information in their area of expertise.
Mhm.
So when they're presented with overly detailed or redundant information that novices might need, these existing schemas get automatically activated, increasing the number of attentional foci that need to be processed and potentially reconciled with that new unnecessary information.
Right.
And this can lead to an overload of working memory and actually impede learning by forcing the expert to process information they already know in a less efficient way.
Hmm.
So they benefit more from concise information that builds directly onto their existing knowledge.
It's really fascinating how this model provides a single framework to explain all these different effects without needing to rely on the idea of these completely separate working memory systems. Now, let's circle back to something we touched on earlier, the role of human movement. So how does this model specifically incorporate the idea that our physical actions can be a key part of how we learn?
This is where the model really offers a novel perspective.
Hmm.
It proposes that human movement itself can be considered another key modality or area of attentional focus. And so this human movement effect that we see in cognitive load theory, the finding that learning procedural motor tasks from dynamic visuals is often better when movement is incorporated, fits really well with this idea. It aligns with the broader theory of embodied cognition, which emphasizes this deep and constant interaction between our cognitive processes and all of our sensory and motor experiences. So it's not just about our brains being in charge. Our bodies and our physical interactions with the world are fundamentally linked to how we think and learn.
So it's not just about seeing or hearing something, but also about that physical experience and engagement. And the article gives that example of how using tangible physical interfaces can improve the learning of complex subjects like anatomy.
Exactly. So when learners can physically interact with the learning materials, for example, by manipulating a 3D model of a heart, it engages their motor system and provides that tactile feedback, creating a much richer and more multisensory experience that leads to a deeper, more embodied understanding. Similarly, we see the power of what are called iconic gestures. So these are gestures that visually represent objects or actions in significantly benefiting learning, especially in areas like picking up new vocabulary in a foreign language or even in how infants learn through imitation.
And the article even mentions the mirror neuron system in the brain as a potential neurological basis for this human movement effect. Can you explain that connection a little bit?
Yeah, so the mirror neuron system, which is a network of brain cells that activates both when we perform an action ourselves and when we observe someone else performing that same action.
Right.
It suggests this really fundamental neural link between observation and our own motor system.
Wow.
So this could explain why seeing movement incorporated into instruction can be so effective, because it essentially primes our own motor system and can facilitate learning by creating a kind of internal simulation of the action. It's like our brains are wired to learn by doing,
Yeah.
even when we're just watching.
And this isn't just in these controlled lab studies. Research in real classrooms has also consistently shown that using gestures while teaching can improve learning across various subjects.
Oh, yeah, absolutely. I mean, gestures seem to act as a really valuable support mechanism in real-world learning environments. And one proposed mechanism for this is what's called cognitive offloading.
Okay.
The idea that by using gestures, we can essentially externalize some of those information processing demands, reducing the strain on our limited mental working memory resources and freeing them up for deeper understanding of the underlying concepts.
And the article also touches on some interesting older research, like Engelkamp's work on how we remember actions we've performed better than those we've just heard about.
Yeah.
So how does that kind of fit into this discussion?
Yeah. So Engelkamp's research, this goes way back, highlighted that we tend to have a much stronger memory for actions we physically carried out compared to just hearing or seeing them.
Interesting.
And his explanation involved the idea of dual coding. So the creation of both verbal and visual memory codes, but it really underscores this powerful role of the motor component in memory formation. And it's interesting to note that traditional working memory models haven't always given as much prominence to these sensor-motor representations in our cognitive processes.
And there's even compelling evidence suggesting that motor information itself can actually occupy space and resources within our working memory, much like auditory or visual information does.
Absolutely.
And the article mentions studies involving American Sign Language as an example.
Yes, research with individuals who use American Sign Language has shown that interfering with their ability to mentally rehearse signs can negatively impact their recall. This is mirroring the kinds of interference effects we see with the phonological loop when we try to rehearse spoken language. This strongly suggests that sign language, which is so heavily reliant on physical gestures, engages working memory in ways that are both similar to and distinct from spoken languages, further highlighting the role of the motor system as a key player in our cognitive processing.
It seems like even Baddeley, the creator of that influential multi-component model, kind of recognized the need to better account for these kinds of physical experiences and how we think about working memory.
Yeah, he did. In some of his later reflections on his own model, Baddeley himself raised questions about how to best incorporate tactile and kinesthetic experiences, so our senses of touch and movement, into his framework.
Okay.
He even considered the possibility of adding further helper systems to account for other senses beyond just auditory and visual. But as the article points out, this starts to raise complex questions about how all these potential systems would interact with each other and how we would explain the intricate patterns of reinforcement and interference that we observe in learning.
Which brings us back to the potential strength of this distributed attention model.
Right.
Its ability to offer a more unified and flexible way of understanding all these diverse influences on how we learn, including this undeniably important role of human movement and physical interaction.
Yeah, for sure.
Now, the authors of the article are careful to point out that, their proposed model isn't a complete or perfect picture. So what are some of the limitations that they acknowledge?
Yeah, so they're very upfront about the fact that their model is more focused on explaining the dynamic interaction between different areas of attentional focus rather than trying to isolate the workings of any single modality on its own.
Okay.
They also acknowledge that one of the big challenges for future research will be to find ways to accurately measure and quantify the constantly shifting allocation of our limited attentional resources in real time. That's a tough one.
Right.
And additionally, the current version of the model tends to focus more on how we process information after we've initially perceived it, rather than on the initial perceptual limitations of our sensory systems. So there's definitely more work to be done.
And what kind of future research directions do they suggest might?